All right, 4.5, using congruent triangles. All right, so I'm going to put it up here just so that you have it in your notes, but this acronym that I wrote on the board yesterday, CPCTC, corresponding parts of congruent triangles are congruent. So a lot of these are going to be like some form of a proof, kind of combining everything that we've done, but now adding in the CPCTC part. Some of them you need to watch what the instructions say. Like these first problems say to like developing proof, and it says state which postulate or theorem you can use to prove that the triangles are congruent. And then explain how proving that the triangles are congruent proves the given statement. So it's not actually asking you to write a proof. It's just essentially like to write the reasons of why that would be the case. So number 8, it says to prove that ML is congruent to QL. And then I've got looks a little more even in theirs, but it's fine. This is P N L M Q. So everything I'm putting on here was given information. All right, so the first thing that it's asking us to do is to state the postulate or theorem that you can use to prove that the triangles are congruent, okay? So essentially the given information is whatever they've given you in the picture. So I know that I have an angle, I have another angle, and I have a side. So that means that it's angle, angle, side that proves that the triangles are congruent. And then from there, they want us to explain how proving that the triangles are congruent proves the given statement. So we want to write the triangles like out as to what they are, like what triangle is congruent to what. So if triangle, let's see, let's do it this way. Let's start here and go to the angle that's the shared or the thing. So we're going to do triangle LNM is congruent to triangle. If I went from L to N, then I have to go to L to P on this one because I've got to get pieces that are matching. So LPQ. Then I can say that ML is congruent to QL by CPCTC. Because this is a congruent part of triangles that we know are congruent, or it's a corresponding part of triangles that we know are congruent, so they have to be congruent pieces. Now, all of them, this won't be the reason. This just happens to be the reason on this one. All right, so notice, it says prove, but I'm not actually writing a proof on this one. Okay, I'm just following what the instructions tell me to do on that one. 10. So same instructions. It says to prove that KL is equal to NL. Okay, so essentially it's saying the measures are equal to each other. And we have all the markings I'm putting on here were given markings. Alright, so first of all, I need to prove that the two triangles are congruent. But I only know two pieces of information that are given to me. Is there anything else that I know? And I will tell you there's two different ways that I could go about this problem.
You can use vertical angles to get an angle.
Yep, so I could use vertical angles to show that these two are congruent. So if I have that, then, so if angle KLJ is congruent.
Where did we get J from?
This is J.
J? I thought it was S. I thought it was S.
So J. Angle KLJ is congruent to angle NLM. And we'd say by the vertical angles theorem. Then I can use what to prove that the triangles are congruent?
Side angle side.
No. Nope. So do I need another piece of information then?
Yeah.
Okay, so then what do I need to do?
Prove that KL is congruent to LN.
Well, that's ultimately what I'm doing, trying to show that technically. What does this symbol mean?
Parallel.
They're parallel lines cut by a transversal. You can look at it either direction if you want. So what does that mean?
Angle K is congruent to angle N.
Okay, angle K is congruent to angle N. So now I have angle, angle, side, or I can look at it this way, angle, angle, side. So we can, or let me do this, let me change this. And angle K is congruent to angle N by alternate interior angles. Then I can say, well, I technically have quite a few options here, I think, because I have, well, I guess not. I guess I only have angle, angle, side. Yeah, never mind. I only have angle, angle, side. So then angle, angle, side allows me to prove that the triangles are congruent. So triangle, let's see, LKJ is congruent to triangle, go the right way, LNM by that. So KL is congruent to NL by CPCTC. However, that's not what they asked me to prove. They asked me to prove that they're equal. So KL is equal to NL by the definition of congruent segments. Okay, so there's different ways I could have gone about this problem. The other way, because these are parallel lines, the reason I was like, oh, there's a second way, is because I could also have said over here that J is congruent to M by alternate interior angles as well. And if I did that, then I could have had angle, side, angle, and done it that way. Okay, so that was another option that I could have had. I just didn't have that marked, so that's why I couldn't do it in the moment. All right, questions about those two before we get into actual proofs? All right. Have y'all ever seen the string game Cat's Cradle? Okay. Well, we're going to be looking at the triangles that come out of the Cat's Cradle thing, but 12. All right, given information is that triangle EDA is congruent to triangle BCF, and I'm going to tell you all of this given information is not going to be relevant to our problem, but I'm writing it all anyways. Triangle AGD is congruent to triangle FHC, and triangle BFC is congruent to triangle ECF. For 12, we're trying to prove that angle CBH is congruent to angle FEH. So I'm going to do my best to draw what this thing looks like for you.
Let's call it a torture device.
Did y'all ever grow up doing those like string games? You get like this huge like loop of string, and then there's different things you do with your hands. That's one of this is one of the things you can do with that to make it do this.
Never did it. My sister would do that.
Yeah, there was one that I used to do a lot that was like crow's feet or something. It was like how you like looped it over and around, and then it like looked like a foot. I don't know.
This doesn't look very
So it's important to pay attention in our particular situation with what we're dealing with. So I care about, I'm going to actually go through and highlight what I care about. I'm looking for angle CBH. So that's this angle right here. That was not a good. So I'm looking for this angle right here. And then I'm looking for angle FEH. So that's this angle right here. Keeps doing that. There we go. Remember, whatever letter's in the middle is the angle that we're like looking at. All right, so all that I really care about in this current situation is that triangle BFC is congruent to triangle ECF because that's the stuff that's down here. I don't care about anything that's dealing with these up here, okay? Now, if you want to write all the given information, you can, but as I do my proof, I'm not going to write it all because it's just excessive to write it all. So, statement, reasons. All right, so all I care about for this one is this bottom piece because that's all that's going to matter for what I have here. So this is this big triangle here and this big triangle here, okay, that I'm looking at. So first thing is triangle BFC is congruent to triangle ECF because that's given information. And I want to prove that this angle is congruent to this angle. So, if I know that the triangles are congruent, okay, that means everything about them has to be congruent down to their angles and their side lengths. What does that mean then about this angle and this angle? They have to be congruent. So, easiest proof ever. Angle CBH is congruent to angle FEH because of CPCTC. And your proof is done.
Never mind, it was fun.
That's it.
It was very fun.
That's it for this one.
What is like 14?
This is the shortest one.
I made like a whole page of
Me too.
and I drew
Just short.
The next one is 7 steps, so
okay, no.
Oh.
we may only get through the next one today. Thank you. Are you all done?
How about I get 13?
Are we going to have homework?
It's Friday.
Because I'm gonna be
It's
cooked.
Friday. It's
I don't know yet.
I will be cooked if we have homework.
Why?
So-
we're doing an all-nighter too.
We're doing an all-nighter for a church event, and that's gonna destroy me.
And we have a competition right after this class.
That's gonna destroy us. Maybe we can make it Tuesday.
Well, we will see. 14. Given B is the midpoint of AD, angle C is congruent to angle E, and BC is parallel to DE. Prove that angle BAC is congruent to angle DBE. All right, so that's what the picture gives us as given information. Now, this is a fill in the blank proof, so I'm going to go through and write all the stuff that is given to you in the proof, and then we'll fill in the blanks of what's left. So, everything I'm writing in blue would have been given to you in the fill in the blank thing. Now, in fairness, this would have only probably been a 4-step proof for me because obviously they do all the givens in a different step, but. All right, so anything that I have left blank would be what you are filling in here.
Actually, it's not horrible. It's not horrible. Look, at least we get to fill in the blank. At least. 'Cause then, no, I don't want to.
18 is the longest one.
Oh wait, it's even. It's an even problem. It's an even problem. Wait.
No, I meant like that we're gonna do. I don't mean like of all of them. I just meant that we're gonna do.
Are we gonna do it? Yes.
Maybe not today, but we are going to do it. All right, so we know that, or we have all this information given to us, obviously. So the first thing is they start with the given. I would have still put all of my givens together like normal, but they did not, so that's why they're in their separate steps. So B is the midpoint of AD. That was given. So then they say that AB is congruent to BD, and we need to state the reason for that. What would the reason be for that? If you need to view the picture. Huh? Yep, definition of a midpoint. We know that these have to be congruent to each other. I don't know why I just put 2 marks there, but it's a definition of a midpoint. Now, I probably would have marked that right away on my picture as soon as I saw this before I even did the proof if this wasn't a fill-in-the-blank proof, but obviously they had it there. So then from there, we have our other given information that angle C is congruent to angle E, BC is parallel to DE, and then we go down to angle EDB, so that's this angle right here, is congruent to angle CBA. So that's this angle right here. So what would the reason for that be? And keep in mind, these are parallel lines right here.
Wait, would it be corresponding?
Corresponding interior?
Corresponding is just corresponding. It's
We
not
did it.
interior or exterior. It's a corresponding angles postulate. So they tell me that the reason has to be angle, angle, side. So that means I need to list the triangles are congruent based on that information. I know that this angle is congruent. I know that this one is congruent. I've now shown that. And then this side is congruent. So I've got angle, angle, side. So somebody tell me, and there's different ways you can do it as long as they both are the same order, it doesn't matter. So what triangle is congruent to what triangle?
CBA is congruent to ED. What's the final one? B.
EDB. So let's check and make sure. So we've got CBA and then we've got EDB. Yep. So I always follow it around to make sure that it matches up. So we've got triangle CBA is congruent to triangle EDB. Now, if you didn't write them in that order, that's fine as long as the order matches in both of them. So then, after that, ultimately we're trying to prove that angle BAC is congruent to angle DBE. So what would the reason for that be?
CPCTC, that's what the lesson's about.
Yep, CPCTC. That's going to end up being a reason a lot.
So does CPCTC or can it be?
It depends. Sometimes it's at the end to show that, like, if you're trying to show that, like, angles are congruent or side lengths are congruent, it a lot of times ends up at the end. But sometimes it's at the beginning when they've told us that the triangles are congruent or we're trying to, like, show. It just depends, but a lot of times it is at the end. All right, here's what we're going to do because we don't have a ton of time and I want us to be able to get through this stuff quickly on Monday with the last ones we have. I'm going to write all the information for the next one that we will do, but I'm not going to do it today because I don't think we have enough time. I think we're pushing it. So yes, you're going to keep this paper because we're going to start on Monday right in with the proof. So 16, you need to write this down. Don't put your stuff away. The given information for 16. This one is a proof that is not fill in the blank. That's the main reason we don't have time for it today. It's talking about bridges. It's a diagram represents section of framework of the, I can't even pronounce it, bridge shown on blah, blah, blah. Write a 2-column proof to show that triangle PKJ is congruent to triangle. Just because I said this is the last thing we're doing doesn't mean we get to start talking. To triangle QMN. So the given information is that L is a midpoint, or is the midpoint of JN. PJ is congruent to QN. PL is congruent to QL. Angle PKJ and angle QMN are right angles. And we're going to prove that triangle PKJ is congruent to triangle QMN. Picture of what this looks like. It's kind of like a 2-dimensional bridge here. So notice what I'm ultimately going to be trying to prove with this problem is PKJ, so this triangle is congruent to QMN. Okay, so notice that it's a little bit different than, like, it's not like the whole big triangle. So we'll set that up. We'll start with this one on Monday, and then we'll finish up with number 18, and then you'll have problems to do, which if you work diligently, you should be able to get through them on Monday in class.